Today, we will be expanding 4x minus 5y to the power of 5 using two methods. We will look at a full step-by-step expansion and a shortcut method as well. Let's start with the shortcut method. So our first step, we're going to see that n is 5, our exponent is 5. So we're going to take a look at the fifth row of Pascal's triangle, and we're going to look at the numbers in that row. We have 1, 5, 10, 10, 5, and 1, as I highlighted in blue. So we're going to take these numbers, and they're going to become our coefficients. So we have 1, 5, 10, 10, 5, and 1. And I'm trying to leave lots of space in between. Now we're going to write our first number inside here, which is 4x. 4x, which with each coefficient, 4x. Just going to write it down. And now I'm going to write our second number in here, negative 5y, negative 5y. So pretty easy so far. Negative 5y. And I'm still trying to leave some space. Negative 5y. And now I'm going to do our exponents. So we're going to start going left to right in descending order of exponents for the 4x. So the highest exponent is going to become 5, 4, 3, 2, 1, and we're going to finish off with 0. Now we can go now from this side, again in descending order from highest to lowest exponents. 5, 4, 3, 2, 1, and 0. Now we're going to add plus signs in between each term. Perfect. Now our very last step before we're all done, we're just going to simplify. So anything to the power of 0 is going to become a 1. So I'm just not going to write that. I'm just going to write the answer, which is 1024x to the power of 5 minus 6,400x4y plus 16,000 x3y2. You can do these on your calculator at your own pace. Minus 20,000 x2y3 plus 12,500 xy4 minus 3125y5. And you are going to kind of see a pattern between the minus and pluses if you have a negative number in your, if you have a negative variable. Perfect. Negative plus, negative plus, negative. Okay, this is your fully simplified binomial. Expanded. Now we're going to expand the same binomial using a second method. So this is going to be our formula that we're going to use. And I'm just going to let you know this is going to be a lot of writing, so make sure that you have a lot of space. So, and then also we're going to be using this version of NCR, n factorial over n minus r factorial. So let's start with the formula. So we're going to start with the NCR portion. So 5 factorial over 5 minus 0, because 0 is our r. Factorial, 0 factorial. And then we're going to write in our x and our y. So our x is going to be 4x. Our y is going to be negative 5y. And then if we see here, we have n minus r and r. So our r is now 0. And n minus r is 5 minus 0. There. That's the first part. Now we're going to do a plus sign. Now we're going to do r equals 1. We're going to do the same thing. 5 factorial over 5 minus 1 factorial, 1 factorial. So r becomes 1, same n. We're going to write down our x's again, 4x, and our y again, negative 5y. And this time it goes 5 to, and the exponent is going to be r. So it's going to be 1. The 4x, the exponent is going to be n minus r. So 5 minus 1. N always stays the same. Now we're going to do the same thing with r equals 2. We're going to add a plus sign in between. Do the same thing, n factorial over n minus 2 this time, because r is 2 factorial again, 2 factorial. You can write down our x, 4 factorial, write down our y, which is negative 5y, and then the exponent on the y is r, which is 2. Exponent on the x is n minus r, which is 5 minus 2. Again, plus sign in between. we're going to write down r is 3 this time. Again, same thing. And then we have our 5 factorial over 5 minus 3, 3 factorial. And then we write down our x, write down our y, write down r's exponent, and n minus r. Perfect. Now I'm just going to do it on the bottom line since we're kind of running out of space. Again, plus sign in between. This time r equals 4. And we're going to go all the way until we reach the value of n. So starting at r equals 0 all the way till r equals 5. So 5 factorial over 5 minus 4 factorial, 4 factorial. We're going to write our x value, which is 4x in this case, our y value, negative 5y. The exponent on the negative 5y is the r value, which is 4. The exponent on the 4x is n minus r, which is 5 minus 4. And our very last one, r equals 5. Last time, we're going to do 5 factorial over 5 minus 5, 5. And then our x value, our y value, and then the exponents on our x and y is going to be 5 and 5 minus 5. Perfect. So if you don't want to write all this out, you can just write NCR, which in this case is 5C0. You can just write NCR, which in this case, for this I mean, NCR, which in this case is 5C1. This would become 5C2. This would become 5C3. So in our next step, let me finish this. This would become 5C4. This would become 5C5. And our next step, when we simplify, it might be easier to type in 5C0, 5C4, 5C1 into your calculator versus all of this. It might just be easier. So now we're going to do our simplifying. So 5C0 is 1. Then you're going to have 4x to the power of 5. And then anything to the power of 0 is 1. Add a plus sign. We're going to have 5C1 becomes 5. 4x4 to the power of 4. And then negative 5y. Plus 5C2 is going to become 10, 4x3, negative 5y2, plus 5C3 is going to become 10, 4x2, negative 5y3. So those two look pretty similar. Plus 5C4 is going to become 5, 4x negative 5y4, and our very last one, 5c5 is going to become 1, and then anything to the power of 0 is going to become 1, and then you just have your negative 5y to the power of 5. Perfect. Now I'm just going to simplify this fully. You can use your calculators, go at your own pace. I'll just be writing the full answer. 1024x to the power of 5 plus, minus, remember our pattern between our minuses and our plus, negative 6400 x4y plus 16,000 x3y2 minus 20,000 x3 x2 y3 plus 12,500 x, y4, and our very last one actually becomes a minus, and it is minus 3125y5. So again, you notice this pattern between the minuses and the plus if you have a negative variable in your binomial. And then, how it works is if you have a on the negative 5y, there's an exponent of 1, which is an odd exponent. So you have the negative. Negative 5y here has an exponent of 2. So you're going to have positive. So if it's odd exponent, which is 1, you're going to have a negative. If it's a positive, if it's an even exponent, you're going to have a positive. Odd exponent of 3, negative. Even exponent, positive. Odd, negative. So odd exponents give you negative. Even exponents give you positive. Great. Now this is our fully simplified expanded binomial done the second way, and you will see that both of these answers are the same. So now after doing both of those different methods together, I'll be answering the reflection question, what are the advantages and disadvantages of each method? So I wrote them down here. Let's start on the shortcut method. The advantages are that it's fast and efficient. There are no formulas required, only Pascal's triangle is needed. Pascal's triangle is easy to memorize if it is not provided, and it is easy to create on your own. Coefficients are easy to obtain by simply reading from the triangle. Exponents follow a clear pattern and are easy to determine. And the last one, it requires fewer steps and much less time than other methods. Now let's do advantages of formal binomial theorem. They work for any power, no matter how large, develops a deeper understanding of combinations in algebraic structure, and this method prepares students for higher level math, like grades 12 and beyond. Now disadvantages of both. It can be difficult to understand why the shortcut method works. Without a formula, the shortcut method can be easily forgotten. For large exponents, finding coefficients and writing many terms can become tedious. And lastly, constructing Pascal's triangle for large powers can be lengthy and may take as much time as other methods. Now, disadvantages of the formal binomial theorem. It requires understanding of factorials, combinations, and sigma notation, sometimes. And it takes longer compared to the shortcut method. Now, I'll be answering the second part of the reflection question. Which method would I choose if I was teaching a grade 8 student to expand a cubic binomial? Well, if I were teaching a grade 8 student to expand a cubic binomial, I would choose the shortcut method using Pascal's triangle. This method is much faster and easier to understand at this level because it does not require complex concepts such as factorials, combinations, or sigma notation. Pascal's triangle makes it simple to find the coefficients, and the pattern of exponents is straightforward. The steps are easy to follow and do not take much time, which is important for grade 8 students. Students should not be spending half an hour on a single problem at this age. And this method allows them to focus on correctly expanding the binomial while building confidence in accuracy without unnecessary complexity. Thank you so much for listening.